Yeah.
Perfect, perfect. Okay, guys, so throughout this module, what we did is we learned an effective method to simplify any Boolean function using what's called kernel map. Kernel map, it's a graphical representation of a truth table, and it's arranged in a cell where each cell here will differ, like, it's labeled by columns and rows. And each time we will change what? Just one variable at a single time. So you notice, like here, I like the A, B, it's gonna be like 0, 0, 0, 1, and here 1, 1, not 1, 0. Okay. Why? Because here we used to have 0, 1, and we will change just one variable. That's why we labeled it by 1, 1. Okay. Now, and after that, like we went over how to get the minimized Boolean function by introducing some of the terminologies, such as prime implicant, is essentially prime implicant. And I made sure that the differences between them are crystal clear in the recordings. If not, so you have to stay with me to the end of this lecture. So I'll guarantee that everything will be clear. Okay. Okay. So, guys, given that this kernel map, so what are the prime implicants for the function g expressed in this kernel map? So the prime implicant is any looping that cannot be looped further. So in other words, like if I look to this guy here, to this one here, this one can be grouped in a quad just once. Okay. So that's why this grouping here is a prime implicant. Okay. And for these four, you see them? Those are a prime implicant. These four are a prime implicant. Now, these two poor ones, they can be what? They can be grouped by taking the corners here. Okay? So we have here, I got all the set of my prime implicants. How did I get them? So for instance, if I want to get these four, so what's not changing here? When it comes to the rows, they're changing all the time. Therefore, just this column, it's not changing. So this column indicate what, guys? If I want to show you here, this is 1, 1. That means A at the true format and B at the true format. Therefore, I choose AB. Okay? Now, for these four, what's not changing here? Not changing is D as well as B. That's why these four are DP. Okay? And for these four here, what's not changing? Okay, admin. What's not changing here? What's not changing is C when it comes to the rows, as well as A. That's why I choose AC. So AB, AD prime, BD, AC are what? Are the prime implicants of this kernel map. When it comes of writing the minimized sum of product, we will choose the groups that will cover all the ones and will remove any duplicates. Okay? Therefore, look at this, guys. Here, I decided to ignore BD. Why I ignored BD? Because BD is not this essential for me here. These two can be grouped. These four, 1, 1, 1, 1, can be grouped just this way. Therefore, there is essential. And when it comes to this one is a poor one because it's only can be grouped in 4 this way. Therefore, I include it. Now, and for these two, they only can be grouped in quad just this way. Now I don't need, I covered all the ones. I don't need to include BD. It's redundant. Redundant prime implicant. Okay? Okay. What about if I try to trick you here by asking you find the minimum sum of minterms for the following function? And this function is written using the product of sum. So what should I do? Either by plotting the kernel map and indicating each term here by 0, and bear with me here, you know, this function has 1, 2, 3, and 4 variables. So each time you need to multiply each term with the missing variable. Okay? Or what you can do is, you know, because we love the sum of products, we can take the complement. Remember, like, you know, the max term is always the complement of the min term. So we'll take f prime. Come on. Okay. And by taking f prime, we can convert this using De Morgan to a standard sum of product format. Okay. So how? Double prime here, double prime, and then no, not double prime. It's just one prime because I'm looking for f prime. And after that, when I take the big prime to each term, I have to change the sign between the terms. Therefore, this one will become the whole thing prime, the whole thing prime, the whole thing prime, the whole thing prime, and the sign will be from and to or. Now, what I have to do is go in and then do the same thing. Now, this big prime can be minimized by taking it to the inside the brackets here and changing this the operation. So this will become an and as long as I'm flipping each bit, each variable. So this will become B prime, and this will become C prime. D double prime will become what? D. Okay. So I was capable using the complement to get the sum of a product notation of this one. Now, it's either you're gonna go and multiply each term by the missing variable to get exactly what are the min terms, or you can use your imagination, you know, and that's what I'm gonna show you now. So that is f prime for me. Now I wanna represent B prime, C prime, D directly without multiplying on the kernel map. So what should I do? I should always find the crossing between the rows and columns that will cover these three variables, okay? So if I want, like, if I have B prime, C prime, D, that means this term was constituted using 2 ones, okay? Because if we have 4, we're gonna have we're gonna have a term with 2 literals. If we have 8, we're gonna have just 1 literal. If we have 1, all of these are 1, that means f equal to 1, so we don't care, okay? So where is B prime and C prime as well as D? So where to find it? Here, guys. Okay, so B prime, I have to look B prime somewhere here and somewhere here for B prime. And then what will give me the exact location is C prime and D. So C prime, I'm like, this is C, so I'm gonna look somewhere here. And for D, I have to look here. That's why I put the ones here and here, okay? Now, when it comes to A prime, B, D prime, that means I have to go and place my ones. It's gonna be 2 ones, okay? In somewhere that belongs to these 2 columns, okay? Now, then I have to select B. Okay, so I will minimize the column, these 2 columns, by taking just 1 column. To find the row, my row will be like, you know, given using D prime. D prime will be here, the deal breaker. Therefore, I'm gonna be either at this row or this row. but this row here will not give me what I want. Therefore, I have to do what? Here and here. Okay? Now, for AB prime D, I'll do the same. Okay? And there will be, like here, I will have my 2 ones here. And after, for ABC, okay, ABC, that is what AB, and C somewhere here. So for sure, it's gonna be the intersection between this one and this one, okay? Okay, now given that I was capable to find the ones that constitute the, or that form the sum of product for my complement function, complemented version of my function, what I have to do is, you know, flip them. That means I will put 0 at each one of the of these ones and place 1 elsewhere. Okay, so that is for alpha prime and this is for alpha. All right. Now, what I have to do is to apply the grouping or looping methods, and that's exactly what I'm gonna do. So what I have to do, I have to go and look at, find the set of my prime implicants, okay? So now I've introduced you so many rules. You can either stick with any kind of rule that you like. So maybe you can group all of them and then decide which one will cover your function totally, or you can do the following. Look, and you will tell yourself that I want to group the ones, since I have 4 variables, I want to group them in a loop of 16 cells. I can't because I have zeros here. Then I will lower my bar and will say, okay, a loop of group of 8 quad. I can't. Now a group of 4, can I? Actually, I can't. Just one way. The only way that exactly. Thank you, Muhammad. So it's just the corners. Thank you. Okay. And why the corners? Because at the end of the day, this is just the 2D version, but in reality, it's a cylinder. So those 2 things are adjacent to each other. Okay, these 2 columns and these 2 rows are adjacent to each other. So what I have to do is group the corners. After that, I can group these, and I can group these, and I can group these, or I can group this one like this one like this one, and this one like this one. So no, Queen Maklowski is okay. You want it? Queen Maklowski is very hard for this level. Well, I'll make a video for Queen Maklowski, but I'm not gonna ask you to use it. Queen Maklowski is, you're gonna take it at the graduate level. Okay, guys. So what I have to do, I group these, like this one can be grouped in a group of 2, either this way or this way. So I'm gonna group both. Okay. And when I group the corners, guys, here, what are the code for the corners for that group? So we will look here. This is 0, 0, and 1, 0. What's not changing here? What's not changing? Just the B prime. Therefore, I took B prime. Or you can do the same thing here. So this column and this column belongs to the complemented form of B. Therefore, you will consider B prime. And when it comes to the rows, here you're moving from here to here. You know, it's something similar that you're going from British Columbia to China. So you will go the other way. Okay, so we're going it this way. So that's why, like, some of the students will ask, okay, but there is some changing here. I mean, you're changing from 0, 0, 0, 1, 1, 1, and 1, 0. No, actually, we're going backward. So 00 and 10. What's not changing here? Just D at the 0 level. That means D prime. That's why I choose B prime, D prime. Okay. Now, for this one is a group of 2. And since we have 4 variables, that will give me 3 literals. Okay. So what is not changing here when it comes to the rows is C for sure. I know C, it's not changing. Okay. And for the column, what's the code here? It's 00, 00. That means A prime, B prime. Okay. Therefore, that group will give me an implicant or a term, which is A prime, C, B prime. Okay. And then I can go forward. Okay. This will give me what's not changing, again C, but here I am moving from yes, here C as well as D. Look at this. Here I have D as well. C and D here. Okay. And here what's not changing when I go from this to this, because these two ones are lying at the first column and the second column. What's not changing is A prime because it's 0001. Okay. Or here, like I have it A prime. Okay. So that's why it's A prime CD. Okay. By covering everything, guys. Okay. And now I'm going to cover this one, and then I'm going to cover this one, and then I'm going to cover this one. Those are my prime implicants. Okay. Because these two cannot be grouped further. Okay. I cannot group them in a larger group. Okay. That's why it's called prime implicant. Now I have to decide which one should I include to cover all the ones. Okay. So when it comes to the essential prime implicant, only the corners are essential. Why? Look at this. These 4 can only be grouped in a group of 4 just this way. Okay. Now this one can be grouped vertically and horizontally. This one can be grouped horizontally and vertically. This one in a group of 2. This one can be grouped in a group of 2 horizontally and vertically. And the same apply for this one. Therefore, only B prime, D prime is my essentially prime implicants. What does that mean? That means that this implicant will be the building block to formulate my simplified function. All right. Now, after that, I have to get the grouping that will cover all the ones. I don't need to get all the duplicates. You know, this is like covering everything here and all the possibilities. So what I have to do, either I'm going to take it vertically or horizontally for these ones. Okay. So what I'm going to do is I'm going to take the group of 4 here. Then I'm going to take this. And for this one, it's either I'm going to take it horizontally or vertically. But since I took it vertically, horizontally, I will continue taking it what? Horizontally. Okay. You might get a different answer by grouping this and this and this. But both, they will give exactly the same implementation of your function app. Clear? Is it clear, guys? If it's not clear, just raise your hand. Awesome. Okay. Now I'm going to move to another way. This example is partially belonging to chapter 4, but I want to show you what kind of examples you might encounter, not in the in the exam, or to be honest with you, at the traditional exam, because I'm not going to give you a big one here at the online. But so you know the code, it's the code for people who are blind, they can't see. If you have like a $20 now or $5, you will see at the corner they have some kind of dots. These dots will tell people that, you know, I can't how to get the number. Okay. Now basically I want to convert from BCD to the Braille code by designing a digital circuit that will do that job. Okay, so what is the first step to do so is setting up the truth table. Now, I already gave you this. So I have this truth table, and if I have zeros, those four combination, W will be 0. However, X, Y, and Z, they will be 1. Okay, that's why I put here 0, 1, 1, 1. Okay. Now, let's go here, 0, 0, 1. Only W will be 1 because there is only a dot that resembles W. Okay. And so on. Now, after 1001, which is 9, what should I include? Can you let me know what should I include on the chat? XZ. Where's Muhammad? What should I include, Muhammad? My mic? Oh, yeah. Okay, can you type? Okay, thank you, Stephen. It's don't care. I don't care. Remember, at BCD, do I care after 9? It's going to be like a new, like in BCD, I only care about the numbers from 0 to 9 because I want to do something that resembles the decimal numbering system. Therefore, 10 will be like a different story, okay? Therefore, after 1001, I will put X's. Don't cares, okay? So now I have 4 inputs and I have 4 outputs. So what I can do is I can get the simplified version of each output and then implement them. So what I have to do now to get W, how I'm going to get W, guys, okay? So remember, this truth table contains the possibilities or the midterms from M0 up to M15. So if I am at 0, 0, 0, 0, that means that's my M0. So what I have to do is I go here, I'm going to look just for my W here, okay? Just give me a second here. Laser point. So I'm going to look just here, guys, here, just for W here. And at 0, 0, 0, 0, W was equal to 0. Therefore, I'm going to put 0 here. Okay. And as a matter of fact, because I'm going to take just from 0 to 9, anything 12, 13, 15, 14, 10, and 11, those I'm going to put don't care for all the functions that I have. Okay. Or all the outputs that I have. So going that the first row, I'm going to put 0. Second one, I'm going to put 1. Where is M1? It's here. Okay. Now, M2 is where? M2 is going to be here. I'm going to put 1 here. And M3, I still have 1. So I'm going to put 1 here. Look at this. Okay. So I'm going to go over all my truth table and place the ones. Now what I have to do, like I have to ask myself, how can I group these ones in a way that will get me all the, like, you know, the prime implicants and the essential prime implicant, as well as covering all the ones. Okay. So how can I? Now I first ask myself, okay, is there any possibility to group them in a group of 16? The answer is no. A group of 8, the answer is yes, because I'm going to use the don't care to my side. Okay. So I can group these in a group of 8, and I can group these in a group of 8. Okay. After that, look, I can't find any group of 8, so I'm gonna stick with the quad. Okay. So that's exactly what I'm doing. Okay, guys. So this group of 8, another group of 8, and then what will happen is I need these 4 to be grouped, so I'm grouping them in group of 4. And for this poor one, the only way is by taking the sides. All right. So after that, I'm gonna get exactly. Now look at this. This group of 8 will give you just C. Okay, a term with just one literal. Okay, guys. Now, and for this one, for this vertical rectangle here that has 8 cells, this will give you just one literal that represent a variable from the column, which is here. What will happen is I'm going to get B. Why? Because look at this. Here, 0, 1, and 1, 1. What's not changing here is just what B. Okay? Or, you know, or by looking to this map here. Okay, now the questions that I want to ask, and for these 4, it's going to be like A prime D, and for these 4, it's going to be AD prime. So what is the cost to implement this function? Now, the cost to implement the function is basically equal to the number of terms plus the number of literal per term. And if your term has only one literal, then the cost to implement that term will be equal to 0. And if your function has only one term, then the cost to implement that function will be equal to 0. Therefore, we have 1, 2, 3, 4, 4 terms. Okay. Now, the cost to implement the first term will be 0. The cost to implement the second term will be 0. And here is going to be 2 and 2 plus 4. So 2 plus 2, 4 plus 4, 8. That's the cost to implement function W. Okay. Now, I'm done with W. My goal then to get what will be the equation for function X here, given that my inputs. So I have to do another kernel map here for X. And here, when it's equal to 0 here, 0, 0, 0, 0, look at here. Here I'm going to put 1 because X was 1 here. Now, when it comes to 1 as well as 2, it's going to be 0 and 0. So I will put zeros. Okay, here when it comes to M1 and M2. So M1 and M2 here, I'll put zeros. Therefore, just 1 here and 1 here for the first column. Okay, and I will continue visiting my truth table and filling the ones. Okay, now I want to group. I have this kernel map that resembles like the output X, and I want to get the simplified one. How I can do so? Unfortunately, I can't see any way to group them in a quad. So I'm going to stick with 4. So how to do it with 4? So the only thing I can see is I can do this 2 once. I can group them in 4. And after that, what I have to do, I can group this one, this poor one, in a group of 4. Okay. Yeah. And unfortunately, this guy will cost me a lot because this is the only way that I can group it down. Okay. And for these 2 ones, I can group them like this. Okay. So that is one possibility of grouping that kernel map. Okay, guys. So we group these like in 4, these in 4, and for this one in 4, and these 2 ones they're for sure like they're essential because I have to include them. You know, they only can be grouped in a group of 2 just this way. Okay. So to get the implicants of these 2, we look here. When we go horizontally, we always have 0, 0. That means I'm gonna have C prime D prime all the time. Now when we go vertically here, The only thing that's not changing is A prime. Therefore, I put A prime, C prime, D prime. Okay. For this one, it's 4. So it's going to be a term with 2 literals. Now, here I have C. For sure, I have C here. And I have to, like I have to include as well as D here. Okay. So it's going to be C and D. Okay. Now, for these 4, it's gonna be B for sure and C. Okay, that is it for B and C. And for these 4, it's gonna be D for sure. And I have to look here what is not changing here. What is not changing is A. Okay, so that's why it's gonna be A, D. That's for X. Now we will repeat the same thing for Y and Z. Okay, let me go like quickly. So Y is here. I'm gonna put 1 because at M0, at row 0 here, I have 1, and then everything is gonna be here 0. So I don't care about that. Okay, I'm gonna put zeros here until I reach 4. 4 is gonna be here, so I will put 1 here and 1 here. Okay, and that's it. Now, how can I group them? I can see that I can group them in a group of 4. This one can be grouped in a group of 4 this way. Okay, by taking the sides, as well as I can group these in a group of 4 by going. Oh, no. I think I can group these 4. Okay, because that is this poor one can be grouped in a group of 4 just this way. Okay, and after that I can group these. That's it. Okay, in a group of 4. And both of them will be like essentially prime implicant. Okay, guys? And for Z, it's going to be the same thing. Okay? Now, after that, can we implement all of these using just an AND network? The answer is definitely yes. So what we have to do, guys, is we use De Morgan theorem by using the shortcut that I have explained. So at De Morgan theorem, remember, like this is the standard sum of product, and if we take the double prime here, okay, so we can change the operation, and this is an AND, this is an AND, and the whole thing is an AND. So you can apply this to everyone, to every single output, and implement it using an AND. If you would like to get it using an OR, what I recommend is you have to get the product of sum and then convert it to an OR only solution. Okay? So that's it for there is no new things that I can explain with you, and therefore what I have to do is I'm gonna open the floor for one-to-one questions. Okay. Who has a question here? Let me see. The cost to implement A, B, C, D is 4. Yeah. Yeah, because you have 4 literals. Yeah, the new date is gonna be Friday. Democracy. Democracy. Yes, we can. You know, it's essentially prime implicant. If you, okay, essentially prime implicant will contain one cell that can be grouped just one way. That's why it's essential. Sure. Which map? Which one you want, Brandon? don't think you can. Oh, yeah. Brandon, which one? This one? Oh, yeah, this one. Okay, this one. For why? Yeah, so what is my goal, Brandon, is to make a grouping as few as I can, and that cover all the ones. So I was doing this, but then, man, like, you know, like if I do this, I still have two ones that are not covered. So I will forget about this one. So if I group these four, and I group these four, I covered every single one in my map just in two groupings. Okay. For assignment 3, question 1, we had the midterm. No, I changed it. It's obvious that there is a missing comma. I change it. Okay, guys, just to be at the same page. Your exam will be on a Friday. Okay. Now, there is an important information I want to share with you. So first of all, I would like to, because like this is the first time you're going to encounter this kind of material using online exams. So what I have to do is I'm going to do the following. I'm going to give you like multiple choices. I think 15. And then I'm going to include 2 questions. These 2 questions, what I have to do, okay, I'm going to give you the way to give me the final answer. However, your step-by-step work has to be sent to one of the TAs. So it's going to be a pool of multiple choices, as well as going to be a pool of questions. Now, once you read your questions, you will include your final answer there. For instance, I will ask you, to design a circuit that will produce high if you have a prime, something similar to the lab, okay? Okay, so, or if I will ask one group, that will be like a question, like design a 4-bit circuit that will detect if the input is even or odd. Okay, like one for even, and the other question will be for odd. And for the even one, you just give me the simplified version. I will gonna give you like a place where you can write your F simplified there. And at the same time, before the end of the midterm, you have to send your step-by-step explanation to the TA. I have 6 TAs. Now, your email has to be sent before the end of the exam. Okay. What I'm gonna do, like starting this week, I'm gonna post some questions. Okay. And some previous exams, even though like even the one at the winter, it wasn't like a real online exam. So what will happen is I'm gonna post it. Okay. I'm gonna post those exams, and I'm gonna post short videos at which you will see me like solving exams just for fun. If you want it, we can do it. If you don't want it, I will stop it. Okay. And the last lecture before the exam, we go an overview and we solve an exam that will emulate your real exam. Okay. So do you have any question for me? Yeah, the exam will be module 1, 2, 3, and 4. But not all of 4. The exam will be on a private space. I will allow, okay, for student, I know what you're gonna ask me. Are you allowed to go back? Yes, you're gonna be allowed. Are you like is it gonna be on bright space? Yes, it's gonna be through the quizzes. Okay, it will not be like similar to the assignment. What do you want me to do? No PDF for multiple choice. I'm not gonna give you a PDF. It's gonna be an exam. Buddy, like PDF is for poor professors, not me. Or I'm not gonna, okay, PDF is for old one. Sorry. Okay. I'm sorry. Okay, not Lul. Stop. Okay, it's for all, like, you know. No, it's gonna be online, where you have to take the exam from 11:30 up to 1, and I will make sure that, you know, I will not fry you guys, for sure that, okay? And I will include a bonus part. Is it good? Bonus, oh yeah, if you want to get like 105 out of 100, yeah. Yeah, and I will not require you to have a camera, or I will not do anything. Okay, you're free to do whatever you want. Yes, you need to email your step by step for long answers. Okay, long questions. The questions that will require long answers, you need to email step by step. Because let me tell you something. If I will consider just the final answer, I'm gonna destroy you. Okay, so maybe you're gonna miss one word, one letter, one bit, then you're gonna lose the whole mark. No, the email of the TA will be part of the question. That's it, buddy. So you, let's suppose, who asked me this question? Ethan. Yeah, Ethan. So Ethan, you will have a question that will ask you to deduct 140 from 200. And I will tell you, like, give me the last answer and send your step by step to Ala, where others may have what, like 150 from 300, and we'll send it to GNU. Or I can do the whole exam multiple choice, but don't blame me if it's gonna be hard. So what do you want? Mixed, yeah, mixed is better. I know that. No, no multiple choice. Listen, man, I have to do multiple choice. I have to do multiple choice, otherwise it's gonna be like a big mess for you. Listen, I'm gonna do like easy multiple choice. For instance, I will ask you, what is the okay, one of the fellow, okay, why digital system is so important? Because they're expensive to implement, one, and because they get like high fidelity output, they're cheaper to implement. Yeah, like they're easier. It's gonna be easy multiple choice, don't worry about it. Okay, and I want you for multiple choice to read the question thoroughly and properly. I can't believe some of you answered the question that I asked you in the survey wrongly. Or it's up to you. That's your opinion. Maybe you're a smart guy and you want to, like, you know, you want to study at the last 2 days, so you will catch up. Yeah. Okay, again, I'm gonna make an announcement for that, and don't worry about it. Before the exam, I'm gonna post exactly the step-by-step a detailed announcement that contains everything about the exam, what you need to do, what you need, you know. I don't need a camera, I don't need nothing about you. And at the same time, what I am gonna do is I'm gonna, yes, yes, I will be online with you guys. I will send you a link so you can ask me if there's something unclear about the exam. Okay. Okay. If anybody would like to speak with me, please raise your hand so I can unmute you. Okay, what do I have to do is so nobody has a question? Okay, you're solid. All of you are solid students. So if you don't have any question, you are allowed to leave.